Hey guys, so I'm kind of just creating this like quick intro because I already created the video. I said, I don't know, long story short, I've been meaning to create like lots of YouTube videos over the last couple of years, but every time I do it, I don't really have anything to really talk about. One, two, I kind of think YouTube, like those YouTubers that like give those really crazy faces on those thumbnails, I'm not really like into that. And three, I've always wanted to kind of build my own business, and so I've been working on my own different businesses for e-commerce and whatnot. But I think like moving forward, the main reason I'm creating this video is because I want to start building something that will allow me to invest into others, whether that be as an angel investor, or if eventually I do create my own like VC, venture capital firm. Probably won't. But I see that there's like many things in this world that like are kind of just going crazy with everyone living in their own echo chambers. And so in order to kind of improve myself and improve the way I communicate and likewise improve my own programming ability, I'm going to just kind of start uploading videos, and they're probably going to be really bad until they eventually become good. As with all things, good things come in time. So I'll just kind of leave it here. This video that's coming up, I go over pretty much machine learning. The very basics of Scikit-learn, I go from just the basics of exploratory data analysis to creating the model. And we're going to be working with the logistic regression, random forest, classifier, and it's going to be classification. So I'll kind of stop here and then get into the video. So thanks. All right, well. Hey guys, so I'm just kind of creating this quick video to go over Kaggle's dataset for heart disease. Now, what I'm going to be going over today is really just a refresher for myself, since it's been a long time since I've worked with machine learning. I've been focusing a lot on the business intelligence side with SQL, and I'm still trying to stay like connected to my emails on my other computer, but I want to just see or test kind of things that I used to know and then see if I remember these things. So this video will probably be best for beginners that are just now getting involved with machine learning, that are kind of curious how you can mix everything from pandas to NumPy, Scikit-learn. And this is just going to be a very basic Kaggle classification data set. And I emphasize classification because this is what we're going to be doing. We're going to be working with this data set, and it's pretty much just guessing whether or not someone has heart disease. So it's binary, essentially, true or false, yes or no, 1 or 0. A classification will generally be 1 or 0, and likewise, if it's like multi-class classification, then it would be trying to get the machine to identify whether it's 1, 2, 3, or 4. Like there's more than one option, 2 options, but yeah, essentially there's just multiple options to pick from. So yeah, so we'll just kind of dive right in. Once I downloaded it, I was able to bring it into my drive, and it was a zip file. And what I did was I first connected to my drive with Google from Google.Colab. I entered the credentials that made me enter, and I used exclamation point ls, bang ls, to see where I was. And then from there, I just kind of changed the directory from pretty much content drive to content Kaggle heart disease. And now this folder lives in my Kaggle folder. And likewise, I was able to open up this notebook by clicking on new, going to more, and then clicking on Google Colab, just in case anyone's wondering. And then if you don't have this, click on connect to more apps and then search for this, and then you should be able to see it. So yeah. So I'm going to go ahead and just dive into it. Once you change the directory to your heart disease, you'll see that you'll have a zip file. And likewise, what I did was I unzipped it with exclamation point unzip, and then I just selected the file. So I pretty much did this and then did that. And then I was able to see that it loaded right here with ls. So right now I'm just going to kind of work on some basic exploratory data analysis. The whole point of EDA is to really just kind of look for outliers, to get to know the data, to see if you have any null values. And I've already kind of done a little bit of that up here. I wonder if I have this. No. Yeah, I'll go ahead and delete these now, and then I'll just retype these in from the beginning. And I'll leave these up though. So because I've worked with this data set a lot in the past, I knew that this would be a perfect perfect way to kind of relearn a lot of like pandas and EDA, exploratory data analysis. So what I've done is I've imported pandas, NumPy, Matplotlib, Seaborne. Probably not going to use Seaborne, but it's there in case I want it. And then let's go ahead and close this. What I did is I kind of already brought in the data set, so I did df for the data set. We're able to see it that it has all these values. I was then going to go and look and see if there's any string values attached by using df.info, and currently they're all integers or numbers, even float. And then likewise I also checked to see if there's any null values or nan, and there isn't. So I'm not going to be converting anything to a string and pre-processing, and likewise I'm not going to be using simple imputer or filling in any of the missing values. You can use both pandas and Scikit-learn to fill in those values, by the way. So yeah, so I've already kind of written like some additional steps what I might want to do, but I'm probably not going to go through these. I will be using a correlation matrix, though honestly if you use the 80-20 analysis after you have filled in all of your missing values, by using the correlation matrix you'll see probably the most important columns or rows of data that you'll want to work with. And I'm actually asking my friend what would be the best programming language for connecting to like a drone, to like an earpiece, or to like other things. I'm trying to learn more about how I can use software and bring it into like a product, which I'm not familiar with. But for this video, I'm just going to stick with obviously this pretty much classification data set. So I've already run the data. I've already checked for null and nan values. Let's go ahead and create some bar charts to kind of just see like what this data has. So let's go ahead and check out our target, because obviously this is a target, so I did value counts. And then S, if I'm not mistaken, df.target. Oh, I didn't import it. Enter, enter, enter. And I got an error. So we don't have it. Did I not connect to it? It's there now, so let's go ahead and see it. So yeah, so this is going to be our target. This is essentially going to be our Y, and we're just going to be saying, hey machine, try to figure out if something is a 1 or a 0. And I'll kind of split this data, so that way we have all of these as X. These will all be X, and then this column will just be a target. So before I do that though, let's go ahead and do some exploratory data analysis. No, I'll wait to do that. So I'll just kind of look at some bar charts. Let's go ahead and look at like how many people's ages there are. df.age.plot.bar fig size equals to 10 by 6. Let's go ahead and see that. This one might be pretty bad. That's pretty good. But I need .sum or .value counts. I would .value counts. So it's been, like I said, a long time since I've worked with Scikit-learn and pandas, but I just kind of wanted to see like what I remember. So with this chart, we could go ahead and improve it by using title, plt.title, and I'll just call it age. And then we'll do plt.x labels. Is it an S label? And I believe this will be the age. So age again. So let's change that, like number of people by age, maybe? By age. And then we'll do plt.ylabel, so we can name our y, the y-axis I mean, and that'll be person count, perhaps. And then plt.x ticks rotation equal to 1 or 0. I don't know. I really don't know the difference between 1 and 0. All I know is this will rotate those values on the bottom. Before they were like flipped to the left, now they're flipped upright. So let's see what 0 does. Now let's see what 1 does. Roughly the same thing, so I'll just leave it at that. Well, what I see from this is we're pretty much have a data set that has the majority of people might be older than 40. It looks like it. It doesn't look like there's too many younger people here. Like there's 129, a couple of 30, but even the 30s, no. Even a couple of 30s. So it's mostly older individuals. Let's go ahead and check out more of this though. So let's look at something else. df dot. Let's look at the columns. Is that how you do it? Yep. So let's go ahead and check out the count for sex, dot value counts. And then we'll do dot plot, dot bar, fig size equals 10 by, no, fig size 10 by 6. And let's go ahead and check that out. Fig size, did I screw that up? Yep, so it is the equals. Equals. And again, see how it's on the bottom, but that's not very helpful. So why would it be a 1 or a 0? What is the 1 or 0 supposed to be? Let's do df.sex. Df. No, we wouldn't have any names, would we? We just have age. So what is sex then? So if we go to Kaggle again, UCI Kaggle, what is the sex? Oh, so sex is male is 1, female is 0. Okay. And then CP, chest pain. I'm probably not going to look at a lot of these since I know that chest pain is very important. Sex is important. Age is as well. I know thalach is. Thalach is the maximum heart rate. I think this is also included. Like, I don't really know what that word is. And then old peak. ST, depression. Well, okay. Maybe not. I don't know. We'll see. But obviously, we're just supposed to be looking at the data right here, right? So let's go ahead and do something that we didn't do last one. So plt.legend. And then, if I'm not mistaken, and then from here, let's see what this does. Let's see if it loads. So we have male. This happened last time too. Should I do this then? I mean, I guess they're both kind of the same. So I guess that's technically right. No, I don't know. Let's try it again with age first. No, let's go up here. Let's just check out. Actually, that would be it because it's just one bar and we're not using crosstab. Sorry, I'm kind of blanking. So let's go ahead and keep going. plt.title. This will be, I guess, gender. plt.xlabel. Maybe I should do that there instead of having a legend. Oops. And then we'll go ahead and do plt.ylabel. What would y be? I guess person count again. plt.x ticks, rotation, 0, and then a little semicolon. So not bad. I mean, this is pretty straightforward. Let's go ahead and make it a little harder. So let's check out the crosstab. So I think, let's go ahead and check out the chest pain and the target. So chest pain I know has values 1 through 3, or 0 through 3 I think. And then the target is value 0 through 1. So if we do pd.crosstab, if we do df.chestpain, df.target, what would that look like? I almost want to plot it though. No, let's just see it. So that's not too bad. So chest pain was 0. People that do not have the disease, 104. People with the disease are 39, but 0. Nothing outside of this really stands out to me. We can always check the outliers with histograms, which I'll do next, or even box and whiskers, although I don't really recall how to make that. So let's go ahead and actually just plot this then for now. So let's do a plot.bar fixed size equals 10 by 6. And let's just check that out. So that's not too bad. Still quite odd. And I wonder if the legend will work this time. plt.legend. What would that be? 1 equal disease. 0 equal no disease. And then we could do plt.xticks because I don't like that rotation. Equals 0. And then let's go ahead and do plt.xlabel. It'll be chest pain count, or perhaps chest pain value. No, that would be confusing. What would that be? So like a chest pain, someone rates their chest pain as 1, 0, 2, or 3. I'll just do value. And then we'll just do plt.ylabel. And then again, I guess we'll do person count. Let's see what this looks like. And then we need a title. So plt.title will be chest pain and disease. Something like that. So not too bad. And we see that the legend populated, so that's good, obviously. Person count, the chest pain value, 0. That's odd though. Isn't 1 is disease, yeah. 0 is no disease. The 0 is showing as less than. Let's check that again. pd.crosstab. Actually, I think that makes sense. df.chestpain, df.target. Yeah, so actually that does make sense. So people that do not, but the blue, that should be 104 roughly. So why is this one there? I guess we'll just flip it. So that way at least it makes some sense, because we want to make sure that this value is actually correlated with what matches. So that should be 0, 0. So yeah, so that makes sense. Next, I'll go ahead and work on that histogram that I mentioned earlier. So histograms would generally be used for like outliers. Really just checking to see if there's outliers. So would box and whiskers, but I'm just going to stick with histograms for this video, I guess. So df dot, how do I do it for all of them? Actually, this might work. df.hist, I think bin equals 15, right? Maybe? No. Okay, so that's almost what I'm going for though. So my idea was to, because there's not that many columns, there's like maybe 6 columns here. No, 10, 15-ish, 14. There's a handful that they can fit all into one picture just like this. So I got this error, rectangle object has no attribute bin, and that's actually why I left this up. So this is one of my older data sets, and I just figured I'd go ahead and look at it again because I wanted to see this one. I thought that this was really cool. I just didn't remember how to create it. So df.hist bins equals 14 and then figure size. So let's try that again. Bins equals 14. Fig size 15 by 10. Nope, still screwed it up. Looks better. So df.hist bins 14, fig size 15 by 10. df.hist. I could copy and paste, but I want to try to remember it. Bins, that's what it was, BS. And then let's actually get rid of that too. So this is actually something really cool that I found on Stack Overflow while I was looking for it. It was really frustrating because I wanted to see all of the columns and see if there was like any outliers, like if there was skewed one way or the other way. But these ones would make sense since there's so little value. Like what I'd look for mostly is like something that has 0 to like 1,000, and then something that's like maybe 1,500, like this 500. I would go ahead and check that out. Maybe 6, but I mean it's not too bad at least. This is one or another. So really we would just look at the cholesterol with someone that has a cholesterol that's higher than 500. And then maybe this one. I know I've checked in the past, but I think for just the sake of this video I'll just kind of show this one. So what would that be? It would be df.col. I wonder if I could do greater than, less than, greater than 500. That's probably not going to work. Maybe it did. I don't know what this really is. Oh, true or false equals to true. Oh, how would I do that? How to find value? No. Find specific value greater than in pandas, or like equal to true. Find value greater than level. df.price. Try this, greater. I'm assuming GT means get. Maybe 500. But what does that mean? So for those of you that are new to this process, or that are just new to machine learning in general, you're going to be spending a lot of time just kind of looking through stuff. And if you don't keep practicing, your memory will fade, just like mine kind of did with this. So yeah. And if you're curious why I'm creating this video, it's because honestly I've been meaning to for a long time. I've been wanting to just kind of record myself coding and just kind of see what comes from it. So we've got df.cholesterol get 500. No, that won't work. Yeah. I'll select a sort column greater than level. Value counts. Select value where target. Select value where target. Good. That's not, I don't even know what I'm typing. Find specific row based on value, pandas. That might be better. Selecting a row in pandas data frame based on conditions. Exactly. Perfect. So instead of using select all from, select rows based on condition. Data frame equals df col, I think it was above 500. Oh, so it was row 85, or index 85, and he does have heart disease. And his cholesterol is 568, or her, I don't know. The sex is a 0. Regardless. And then they have the thalage of 3, which I know matters. Xing, I think, also matters. Or actually, this thalage matters. Okay. So now we know how to identify someone based on where they're from. So data frame, within this data frame, cholesterol greater than 500. And if you're curious, you could always do like equals instead of greater than. And then you could do like equals like true, or even apples, really kind of whatever you're looking for. Just it would be like the where clause in SQL. So where something equals blank, you would use something like this. So let's go ahead and leave this as 500, greater than 500. It's a slow day. 500. Perfect. And then what else do I want to do? So like we kind of checked for an outlier, and if we wanted to, we could always do a drop. I wonder if we would do like dot drop, df dot drop. Let's figure out how we could drop this one. Df dot drop, and then I'm assuming we could do this. Let's go ahead and check this as like df2. Save it as df2, and then we can do df2 equals blank, and then we'll do like df2, and actually let's do greater than, I'll just leave this for now. Let's just see what happens. So you get an error. Not found in access. That's right, we need row access equals 0 because it's a row. Oh, to drop specific value. Specific row based. Actually, I wonder if he has drop. How to drop rows in data frame by condition. Let's see what happens. So data frame, index, picture, import pandas, details. And for those of you that are curious like why the screen's black, it's because I'm using this dark mode. I personally need it dark so that way it doesn't screw up my eyes. Get names of an index for which column there. Drop these rows with the index. So df.drop index name. So this would be the index name. So essentially you could just copy this, paste it there. And then in place equals true. That's right, in place. I forgot about that. So let's try it again. So we do in place equals true. So no. What we would do is we do df. Oh no, I just reset this. I shouldn't have done that. Oh well. df.drop. Yeah, let's actually change this. Let's change this one to 2, 2. So then I have those saved, and then let's bring back in pandas. So the reason I'm doing this is because when I saved it as just that single row, all of the other rows were just deleted or pretty much removed because I overwrote the variable, wrote over, you know. So let's bring these in, and then let's go ahead and see what this does. Now we're back here. Now this is df2, so it'll be a little different. And then, so df3 equals df2. No. I already forgot. Actually, that was kind of dumb. I shouldn't have done that. Yeah, no, that makes sense. So we're working with data frame, so it's not this variable. So we still have the variable, but we're saying where it's equals to this, we would also need .index, if I'm not mistaken. And then before I look at it again, oh no, yep, of course. Let's bring it back in. And then that will be 3, df, yep, perfect. Dot, I hope it's index. Okay, it's not callable. What was it then? No. Dot index without it. That's right, not callable. No, we have df2. So df3, and then let's go ahead and use df2. And for the sake of trying to remember, what's the recall? df.drop index names in place true. Dang. In place, so it's not axis. Equals true. Let's get rid of you, and then let's go ahead and check out data frame 3. Honestly, it should actually be nothing. Nothing should populate, I believe. Invalid syntax. Yeah. Well, that was... Oh, wait, no. Come on. Yeah, so nothing populated because this doesn't actually have any rows. But if we looked at df2, we would see dot head, maybe? Nope. Okay. Good stuff, Doug. Oh yeah, because it's the index. So you're indexing it. You're saving the index. I'm just thinking out loud. But I guess the point would be if you wanted to locate something, go ahead and use this. So let's move on to scatter plots. Scatter plots will generally allow us to identify if an object, or like if a column, histograms, like what the trend is. So if the trend is going up or down or stagnant perhaps, or just there's like no trend at all, is it linear, whatever. Let's go ahead and create a scatter plot. I don't remember how to do this, but I do know that's here. But let's go ahead and see if I can figure it out. Plot plt figure size, fixed size. I don't know why that would work, why that is. So I did this last night, and I wanted to create a video then, but it didn't really work with scatter plots. I was really screwing up with those. plt.scatter, and then we'll do df.thalach, and then df.age, or is it target? It is target. Target. Oh, well, that's good. Equals 0, if I'm not mistaken, and then down here, so that would be the x, and then this would be the y. That's right. And then this would be like age. So we're comparing like two different columns against their target. So whether it's a 0 or 1. And so df.target. I feel like I screwed this up though. No, I guess I did alright, because this one would have engulfed it as well. And what I mean by that is it would have looked like this. You would have been... I feel like that's way more wrong. It is. I'm just going to leave it here for now, and then we'll just kind of see what comes. And then we'll do like color equals salmon. Salmon. And let's go ahead and see what pops up. Yeah, figure size. So how did I do it? How did I do this scatter plot? Let's see what the first line of code is. plt.figure fig size 10 by 6. plt.figure fig size 10 by 6. plt.figure fixed size 10 by 8. That's fine. Alright, we got a dot. That's wrong. So how did I do it then? So df.age, df.thalach, target equals 1, 0. And then how did I do it? Thalach age, Thalach, same thing, target, target. So those were right. Is it though? Let's go ahead and copy this. The reason I keep going back and forth, I'm trying to remember these things without actually copying and pasting, is because I want to try to remember these things again. So this is 0, so plt.scatter, df age, Thalach, equals to 1, comma, comma. So it's the same thing, df Thalach, target 1, 0. Let's go ahead and copy this again. Paste. Let's change these to actually. So is that it? That is it. Wow. Okay. So I was almost there. Let's get rid of you, and we'll change these to 1. 1, comma, salmon. Let's go light blue. And let's go ahead and see what happens. I get an error. That's right. Get rid of you. Interesting. And then what else was messed up? I wonder if it was like sky. No, that wouldn't matter. Would it? Let's do sky. C must be a color. Sky blue, perhaps? I don't know. Make this like blue. I don't like that color though. So let's do. Could have swore light blue was 1. No. Was it underscore? Let's go ahead and check colors for matplotlib. Matplotlib.colors. So Salem, let's see if that pops up. Nope. Normalization, class, function, API, color bar. I just want pictures. Specifying colors. I mean, you could, but I don't want that. So those are kind of cool. Where's the color? Color C0. Interesting. So that's Seaborne, that's default. Seaborne obviously looks way better. I just don't know it enough. What else we got? So we have black, blue. I could have swore there was, yeah, light. Wow. Okay, so one word. Light blue. Nope. Come on. Yeah, so that looks better. I'm not going to bother with that. It's fine. Cool. So, what does the blob tell us? It might be going down based on the Thalach. So what is 1? So light blue are the targets. Let's flip these actually. So it's a little easier. So the targets are here and they seem to be going down as this increases. But when it comes to light blue, I'm not sure that really matters. So this is also a person's age, their Thalach score. So I'm guessing it decreases as people get older. Except this one's like way out there. So it's really high. And they seem to be clustered around here as well. And then even though people get older, so right around maybe like 150 might be a little high then. So yeah, so when it comes to exploratory data analysis, it's mostly just checking the data itself. What else is there? So we have describe, and then we'll go ahead and do the correlation. Describe. This is also going to be useful for checking if there's outliers. So if you have a mean of 54, you'd expect the max to be roughly equivalent, but if you have maybe like a mean of 3 and then a max of 3,000, maybe you'd get rid of that column. Yeah, this could be a way of also checking for outliers. Targets, basic, Falach, and so on. And then let's go ahead and check out the correlation matrix, because this is honestly the most important part, I think. So this correlation matrix will show us where the target is, and pretty much you notice age with age, it has a 1. Sex with sex, it has a 1, and it kind of keeps going down. Chest pain, I don't know what that is. The cholesterol with cholesterol, it shows 1. The higher it is, I believe, or the closer to 1, like a perfect 1 right here, that a column is with another column, means that they're correlated with each other. And so let's go ahead and turn this into a heat map. So if I import, which I already have as Seaborne, so how would I create a heat map with Seaborne? So we have the fig and the axe. I do remember that. Let's do core matrix equals df.core, and then from there I think it's this equals plt.subplots. Oh, I feel like I'm forgetting something. And then when I forget, I think there might be like sns.heatmap. Where would that be? sns.heatmap? Okay, actually it would be below this one. sns.heatmap, heat map, and then I'm definitely going to blank on this one. So what would this be? Correlation matrix, good. plt.subplots, I'm thinking that this is fig size, 10 by 15 by 10. And then let's see if I remember this. So core matrix, and then it goes, so we already have this populate, so that's good. FMT equals, I think it was 0.5? No, it was 0.2 F, 3F, 2F. I believe that that will give us the what is it? The numbers after 0, like how many values come after 0. This like rounds to 2, you know. And then I think it was heat map. So what else is there? CMap equals, oof, I forgot what it was. Yellow, blue. I feel like that's messing it up. And then there's one other thing that I needed. What would it be? So we have the data, center, the CMap, which we need, robust, annote. Annote might be it. Annotation true. Let's do annote 2. Annote equals true, I think. Or is it C bar? Let's go ahead and run it, see what happens. Probably got the error. So we have this. Is not of, so that's kind of cool. All right, what do we have then? This was it, yellow, green, blue. But we have all these other colors too, so that's kind of cool. Well, let's see. Nice. I'm glad I remember that. I used to spend hours looking at this thing. So I was right. So the FMT will give us the, like, round it to 2, like values after 0, 2, and then just rounds it up. If it's a 5, it goes up by whatever this is. If it's 0, then it goes down. You know. So which columns are the most important? So I see so far 0.43 is the highest. Is there any other color though? 0.3. So it looks like, what would these be? The target and the sex. No, chest pain. Chest pain and target are quite high. And then what else with the target? So the Falach is quite high as well. And then likewise the slope is also high. But I thought chest pain would be high. I guess not. It's actually really interesting because I thought that the chest pain was one of the most important ones. Did I make that right? So I'm going to go back to this one just to kind of see. I know true, line with I mean, I guess I could have done that. Yeah. So let's go ahead and paste that there. And then we could also get rid of it, rid of that little squiggly up top that was here. Okay, and then you can add a title and all the rest of the good stuff, but I'm not going to. And then if you want to, you can even save it. But what do we got? So just some interesting stuff. Now I think I'll just go ahead and create the model since it's been an hour and I'm probably should get back to doing some other stuff. So let's go ahead and import Scikit-learn. So let's check the metrics and then the models as well. Yeah, so let's do metrics first. Scikit-learn metrics. From Scikit-learn.metrics import accuracy score, precision score, F1 score, recall score, and then from Scikit-learn.metrics, I think that there's more, but I don't remember. Yeah, I don't remember. Maybe ROC curve? AUC curve? I honestly don't remember how to do that one. What else is there? Correlation matrix? No, it was I think it was this, classification report. From Scikit-learn.model selection, import train test split, grid search CV, randomize search CV. What else is there? From Scikit-learn dot I don't remember the rest of them. I could do, because we're not doing pre-processing, if we were doing pre-processing, I would do pipeline and a bunch of other stuff. One hot encoder, simple imputer, column transformer. Let's just go ahead and import the models then, or like the classification from Scikit-learn dot random ran ensemble. Import random forest classifier from Scikit-learn.svc, svm, what is svm? Import linear svc as well. From Scikit-learn dot, what was it, neighbors. Import k neighbors classifier from Scikit-learn dot linear model, import logistic regression, and then from, was that it? 1, 2, 3. Yeah, so there's only 5 that I was actually going to work with then. Cool, so we've brought in this important information. Now let's go ahead and actually split the data into our X and Y and Y train and whatnot. So np.randomSeed. The reason I'm using numpy.randomSeed is to make sure the data stays the same so other people can mimic the results. So let's go ahead and split it. So we'll do X train. No, we gotta do X and Y. X equals data frame. Do we even still have the data frame? Is it fine? I think it is. Yeah, it is. Let's actually check the shape of it first before I move on. Yeah, okay, so it still matches. So it's rows by columns, 302 rows to 14 columns. So x equals df.drop target. Target axis equals 1. And then we'll do y equals df.target. And then from there, let's go ahead and do x train x test. ytrain ytest equals train test split xy test size equals 0.2. And let's go ahead and let's check this out. Xtrain.shape. And then what else? xtest.shape. Test size is not defined. Train test split. Oh, equals. Yeah, obviously just see to make sure that we split the data correctly. So yeah, so xtrain xtest, ytrain ytest, train test split, xy test size. What else? I guess that's it. And since I don't need to fill any missing values, and likewise I don't need to convert them to a string, I guess I could just create the model. I could fit it. I feel like I'm forgetting something. So let's just figure it out, I guess. How would I do this? Okay. So if I remember correctly, what we're going to do is we're going to create a dictionary. Because we're using 5 different models, I want each model to be fit and scored. Yeah, fit, scored, and then we can use cross-validation. That's what it was. Cross-val. Is it this one? No. Yes? No. I don't know. Or is it perhaps this one? Learn.model selection. Import cross-val score. Yep. I was missing that. So that's fun. Then this will work again. Meh. Now let's go ahead and create a function. So df the metrics, so the models actually, let's do that. Models equals this, and then we'll create a dictionary. So this will be, let's do logistic regression. And I don't remember if I instantiate it here or later. Logistic regression, is it here? If it is, we'll fix it. If not, and then random forest. I'll just do random forest. Random forest classifier, and then we'll do linear SVC. Is that right? Yeah. And then, so some of you are probably wondering why I'm doing the linear SVC, or even nearest neighbors. And honestly, it's because I've learned that you really don't know what will work unless you try it. And personally, I'd rather just run it against all metrics, even if it's not really built for this specifically. Maybe it works, maybe it doesn't. You never really know. Oh yeah, SVC. SVC, based on my limited experience with this. So logistic regression, random forest, linear, and then k neighbors, knn for k nearest neighbors. K neighbors classifier, boom. All right, and then from here we will do define, fit, and score. And then we'll do model, and then we'll do xtrain, xtest, ytrain, ytest. I think that's it. What else would I need? I don't know. Xtrain, and then we could do some indentation or like annotation, whatever. Model equals model. Xtrain equals xtrain. Ytrain equals ytrain. Xtest equals xtest. Ytrain. We could obviously make this better, but you know, ytest. What am I doing? Come on, ytest. I feel like I'm forgetting something. If it comes to me, it comes to me. So what are we going to be doing? We want to create a for loop. I'm also going to need to either create a list or a dictionary list for model input. Oh, I'm so blanking. Okay, come on. So for, I just remember this part. We have model name. Let's do, oh yeah, numpy.randomSeed. numpy.random.seed again to make sure that populates 42, 52, whatever. No, let's go 42. And then we'll do model name, I think, equals empty list. Ah, gosh, I feel like I'm screwing up. So for model, for name, oh, I'm so blanking. For name, oh my gosh. For name model in models, like key value. Model.score, oh yeah, no, fit, model.fit. I think it's model. And then model names. Oh, I am so blanking. So the reason I keep saying that is because I actually memorized how to do this at one point. I understand that creating a function, obviously you'd want to go through it. You'll go ahead and do a bunch of stuff. You could do self, you can instantiate it and have a class and all that good stuff. But yeah, let's go ahead and cheat. So we have this. We split the data. Model.dict. Damn. So it was model.dict, random seed. So we're creating an empty dictionary to store the data. Model.dict. Model name, model.dict. And then I believe it goes here. Blank. And then for name model and models.item. Come on. For name model and models.item. And then model.fit. Model.score. I thought that the X train, Y train, that's right. Model.dict name, that's what it was. Model.dict name. So why is that? Let's do this first. Model.fit. Y train. And then it would be model.score. X test, Y test. So what's happening? Well, we have models up here, which is in the dictionary. With the key, we have the value. And there's an empty one to go ahead and store. Store model, store data, I guess. That's easier. Replicate data. And then the for loop. For name model, key value, and model.items. So this would be the key, the value, model value dot fit, X train, Y train, model dict name here. It's being stored here though. Model dict name. Yeah, so we have the name equals model.score. Did I do that right? Yeah. And then return model dict. Model dict name, okay. Yeah, okay. Return model dict. Okay, let's go ahead and test it out then. So how would I do this? Let's go ahead and save it. So I know that we're going to be saving it, and it'll be a dictionary. So let's just do like model score, scores with an S, equals fit and score. model okay, I don't need to do that. Model equals model, and then x train equals x train, x test equals x test, y train equals y train, y test equals y test. So let's go ahead and enter that, boom. Let's go ahead and call model score. Let's see the type before I do this. If I think it's still a dictionary, yes it is. Nope. Model, models, dang, okay. Equals models. Item, y test, models item. The items. Did I do that? Yeah. Dang. Y test. Okay, so there you go. So it is still saved as a dictionary. Now I could go ahead and transpose it and see each of these as a bar, but what I want to do is, I don't remember how to do it with Seaborne, but there's a really cool way of making this look way cooler, and I want to be able to have the values show above the bar chart. So let's go ahead and turn this into a bar chart, and then we can see which of these did better with a visual, since personally I'm visual, but I do not at all remember how to do that. So this would be an example of how we could transpose it. What we do is we save it to a pandas data frame, and then we go ahead and call the index as the accuracy, and essentially we'd be able to see these transposed into each of their own score. But I want to be able to see the score with the value above here, and I know we'd use plt.text, but oh no. So nope, I'm not going to do that just yet. What I am going to do is, shoot, I'm going to need to figure out how I did it with Seaborne last time. So I'm horrible with Seaborne, but let's just look this up. Heart disease. No, it wouldn't be that one. Oh, shoot. So I decided to go ahead and actually look through my old files for the Seaborne. Long story short, it took me like 3 hours last time to try to figure this out and like how to fix it. But ultimately what it does is pretty much just creating a bar chart, and it's going to look nice when we implement all these. So we're able to actually see the values above the bar. So what do I just need to update? So we have the evaluate the model. I just need to change the dictionary name. Come on. And then I think that's it. Let's go ahead and run it. Yeah. So it took me a while to figure this out last time, but I really wanted to be able to see this up here. Mostly because I just think it looks nicer. Like if we compare this to like just a regular bar chart from Matplotlib, you know, like this is cool, but it would be always nicer to have the values above it. Now I'm not as advanced with Seaborne, but this is pretty much what Seaborne offers. It just obviously looks nicer. So with that said, we've now kind of seen and created like a model. We're able to define it, and the next thing would be to go ahead and look at the metrics. So I kind of decided that because I've been working on this for a while, and because I don't fully remember how to do the metrics, I'm going to go ahead and skip on them. I would be able to create a pipeline if if I remember correctly, I'd be able to create a pipeline, and I'd be able to adjust the n estimators, the min samples leaf, the min samples whatever else for random forest, and likewise logistic regression. I believe there are like 2 hyperparameters I can adjust. But with regards to the rest of these, I'd still need to do some research, and likewise I would need to, I'm not good enough, I guess, or I don't remember how to build the pipeline for adjusting the hyperparameters to include these individuals as well. I know I'd use pipeline from scikit-learn.pipeline, import pipeline, but from there, I don't know, I would pretty much have to go back and check it out. So I'll go ahead and stop here. So I want to thank you guys for checking out this video. I'll likely work on another dataset classification, and I think I might just do it like every day for a month classification, and then every day for a month will be regression, scikit-learn based. Currently I'm working on recurrent neural networks in PyTorch, and that's been like my main driving force, because one of the MVPs that I'd like to work on includes natural language processing. So my main focus really shifted from scikit-learn to deep learning and AI, and I think the 80-20 analysis, at least I'm guessing, that the majority of my work, if I was to build out that business, would result or would come from deep learning and using, yeah, just deep learning. So I'll stop here. So thanks for checking out this video. I'll create many more. They're likely going to suck, but yeah, eventually they will improve. So yeah, so thanks for checking this out.